Okay, so let's talk about how we can actually apply the drive constraints and create motion in this particular assembly. It's a little bit tricky, and Inventor doesn't make it easy, but let's see the steps that are required to do this. So it's not a powerful function and it doesn't have a lot of flexibility, but you have to approach it in a very careful manner. So if you click on the shaft here, we need to right click on it and make it grounded so it's not spinning anymore. This will be our fixed shaft in this case. Then we have the wheel here. So the shaft, I'm going to expand. The wheel, I'm going to expand as well. And we need to find the planes that are slicing the part in half. So we can look at the X, Y, Z and expand here and look at the YZ as well. And it looks like they are pretty much aligned. So click on the constraint icon or click C on the keyboard. Click on the angular one because we want to spin it. Direct angle, so just to keep it simple, YZ and then YZ here. And you notice that it doesn't really move, and that's when you have to kind of key in a few values to see it move. If it doesn't, what I found best is to grab the arm and swing it around this way. Let's say somewhere over here, and let's attempt that again. It's very picky on how you do it. So again, angular, simple, YZ. You see how it moved and it did that click? That means it's actually there is acceptance from the software on this movement. So I can actually key in, let's say 45, and it would move, or key 0 back in here and it would work. So if I click OK, it doesn't really like it. So if you escape, like I said, it's very picky. So constrain this one here, YZ, YZ, it moves into place. We're happy with that. We'll just click OK, just so we can establish something, because it is pretty tricky to get it to accept the constraint. And once I have the constraint, which is the angular here, if I right click on it, I can click drive. And that's when you can actually key in a value, let's say 100 in this case, and I can play that. You can see it moving. I can play it back to return to its original position. I can push it to 120, let's say, and it would do that for me. So you can see it going a little bit further and return this way. You can even do a minus here. So if you say minus 100, you can actually push it towards the left a little bit more, and you can even key in, let's say 120, and push it further. So you can see that's trapped between plus 120 to negative 120. If I'm happy with this, that's really all you really need to do. You can actually record that motion. So I can hit the record button, pick AVI because it's a better quality, save the file. Let's just say constraints steam engine, and hit save for that. I like the Microsoft Video one, but there's several other codecs you can pick or compressions. That's usually the most stable one. And we just have to basically reverse. And it's going to actually go ahead and record that action for us as a video. It's doing it slow, of course, because it's trying to capture all those frames. And I'm going to return it the other way as well. Now that it finished going around, I'm going to simply hit OK. And then you can open the video that you produced. And if it doesn't open up right away, just simply right click on it and open it in VLC, because it happens to be a better video player. So you can see VLC is able to open the video. You can see the motion in the assembly happening exactly as it was intended. Again, it's a very finicky function, not the best in the world, but it is possible to make it drive the motion if you work with the software and apply the parameters correctly and very carefully.